Alright, good morning guys. So for today we're going to continue talking about stats, but we're going to be looking at different shapes of data displays and what the shapes can tell us about certain information. So just to kind of begin, we're going to do a little recap on three main statistical measures here. The first one is the mean, alright? So we got to remember that the mean simply just represents the average of the numbers, okay? So in this first problem, we have the temperature, okay, measured through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 days. Okay, so to simply find the mean, all we're going to do is we're going to add all of those measures together. Okay, so I'm going to take a calculator here and I'm just going to measure all of the degrees. 75 plus 73 plus 72 plus 75 plus 73 plus 75 plus 76 plus 90 plus 95 plus 95. Okay, and I get 799, and we're going to divide that by 10, so I get 79.9. So the average temperature across these 10 days is 79.9, or the mean. Okay. Now to find the median, we need to take these and we need to list them in order, because the median is the middle. Okay, so I'm going to go ahead and list them, starting with the lowest temperature of 72. All right, I've used 72. I've got two 73s. All right, 73 and 73. I've got three 75s. I've got a 76. I've got a 90 and two 95s. Okay, so I've listed those in order, so we're just going to count into the middle. And where there's 10, I think numbers 5 and 6 should be in the middle. So here, go here, go here, here, and here. So these two represent my middle. Now, because there's two, we would want to take the average of those. But because they're the same, we can say my median is 75. Okay? The mode, okay, easy way to remember this, is the most. So which occurs the most? Most is 75. Okay, so when we think about these, so if you look at the numbers, the majority of the numbers, okay, are down here around 75, right? And then, but then we have a couple here that are a little bit greater. So notice that the mean is greater than the median, okay? And so when we think about which of the three measures represents or is the most accurate in terms of representing this, okay, we would probably say the most accurate depiction of this is going to be the median. Okay, well, why? Because 7 of the 10 temperatures are around that temperature, but then at the end of the week, 90, 95, 95, the temperature just jumps up. Okay, so the median is a better representation. Okay, and so how can we describe the data? So if you were to think of like a box and whisker plot right here, where we start with 72, the median is 75. So like remember we did those 72. I'm just going to count by twos. I'm going to jump out here to 95. So I've got my lowest point here. My median is at 75. Right, the next one in between there is 73. So that lower quartile is made up right here. The median of the next temperatures is probably about 92.5. All right, so all the way right here. Oops, sorry. Okay, and then the high temperature is right there. Okay, so you can see that the median, that the lower sets of temperatures, right, they're concentrated together, and then there's a large jump, okay, up to the end of the week. So we can say the lower 25% include from 72 to 73. The middle interquartile range is from 75 to 91-ish, and the upper 25% is from 91 to 95. Okay. All right. So that was just kind of a warm-up, just talking about mean, median, and mode and what those represent. So now we're going to go and take a look at example 1 and look at, once we have these histograms here, okay, how we can kind of interpret that data. Okay, so for example 1, we've got a histogram that shows the weights of all of the dogs entered into 2 different categories in a dog show. All right, we're going to consider each set and see what kind of inferences we can make about this. So now notice right here, okay, we've got a histogram where the majority of the dogs are kind of in this middle range. And so they've already interpreted this to say that the mean and the median are both 45. All right, so the average and the middle number are the same. Okay. The second one, though, I notice that we've got the big bump over here. Okay, that says the mean is 27, the mean is 24. All right, so the average is greater than the median. So this one's going to be kind of like our example up here where the average was greater than the median. Okay, and so we're going to look at some terms that will specifically describe these 2 situations. Okay, so the first one, we say that this histogram is symmetric. Okay, it is symmetric, and it shows that the data are evenly distributed around the center. Okay, so we can see here that if we were to like fold this over, that it would fold right on top of each other. So here we say the mean and the median of the data are equal or almost equal. Okay, so they're about the same. We can say that it's symmetric. Based on the data, we can infer that most of the dogs in the category, all right, we can probably say that most of them weigh between 30, in these 3 big humps here, we can say that they weigh between 30 and 59 pounds. All right, so that's where the majority of them, and then we've got some smaller dogs here, and we've got some larger dogs here that kind of fit outside the mean and the median. Okay. All right, now on this one over here, okay, this one's a little bit different, all right, because the data is a little, so here, notice that our big hump, the majority of our data is right here. But then we've got these ones out to the right. So we say, in this histogram, this shows that the data are skewed right. Okay, it's skewed to the right. Okay, and in this case, the mean is greater than the median. So typically, our median would be right here. But because we have all of these data points over here, that's going to make the average increase. Okay, so we say the mean is greater than the median. So based on the data, you can infer that most of the dogs in the category, all right, still, even though we're skewed right, most of the dogs in this category are probably going to weigh less than 29 pounds. All right, because they're still centered here, but we have this that skews the data to the right. Okay, so just like in our example up here, most of the temperature days were in the 70s, but we had this data up here that kind of skewed our data to the right. All right, it caused our average to go up higher, even though most of the days were in the 70s. Okay, and so that's kind of what this is doing. These heavier dogs, all right, are skewing the data. All right, they're making the average go greater than the median. Okay. All right, so the next one says, suppose a third category of dogs has a mean of 40 pounds and a median of 32 pounds. What can you infer about the dogs in this category? Okay, so if we have an average of 40 and a median of 32, anytime the mean is greater than the median, this is going to be skewed right. Okay, it's going to be skewed to the right. All right, anytime the mean is greater than the median, it's skewed right. Right? All right, so let's go and take a look at the next page, and we'll kind of write some rules for the skews. All right, so when it is symmetric, we say the data are evenly distributed around the center. All right, so you're going to have something that when you draw it, kind of looks like this. Skewed left, right? When your histogram, you're going to have data on the left that bring your average down. Right, so the mean weight is less than the median. Skewed right, I didn't mean to draw that, sorry. Skewed right, okay, the majority of your data is going to be on the left, but all of these little data points over here are going to cause your average to increase. Okay, so we say that is skewed right. Okay? All right, so we're going to look at a couple other examples and how we can kind of use this to interpret the information. So let's take a look at examples 2 and 3. Example 2 says, so here we've got customers at a bagel shop that complain that some of the bagels weighed less than the amount on the label. a quality control manager randomly sampled 30 bagels, right, and weighed them. Based on this sample, is a change in the process of making bagels warranted? So basically, we want to see, right, do most of them weigh what they should be? Okay, and so if we look here, notice the shape of the graph, right? I'm coming here, right? So notice how we have all of these data points right here. Okay, so we say that this is skewed left, right? This is the skewy part, right? And so sometimes we call this a tail, right? It's the tail that's on the left side, and so it brings the average down. So notice the mean is less than the median. So this is common when the mean of the data set is less than the median. Okay, we just talked about that. Okay, how does the skewed data affect the mean in this context? So the bagels that weigh less bring down the mean, okay, or the average. Okay. So the question that we're asking is based on this, should he change something about it? Well, in this typically, because we only have a sample of 30, right, that's not really a big enough sample, right? So we're going to go ahead and take a look down at the next one to see if we need to change. Okay. So now example 3, we have the same type of thing, but the manager, he generates a second random sample of 30 bagels. Okay. So we're checking to see if a change is warranted. So now this time, notice that my tail is right here. So this one is skewed right. Okay. So here we can say that the baker should not make changes unless he uses a larger sample size. Okay? Because one example was skewed left, one example was skewed right, right? So we can't really tell what's going to happen here. All right, so the baker should not make changes unless he uses a larger sample size. All right, let's take a look at the last page. Ooh. So we got a couple examples. So for example 3, we're going to continue this. So why does the manager not recommend the changes based on the data? Right. So here this is just an explanation, but it says the shape of the data displayed is skewed right. This often occurs when the mean of the data is greater than the median of the data. Okay. So in this example, the mean is greater than the advertised weight, and the greater the mean weight from the first sample. Okay. The manager could not recommend changes. What does the shape of the histogram for the second sample tell you about the data? Right. It says the larger bagels, okay, increased the average. Okay. All right, so we're going to continue this example with example 4. This time it says the quality control manager generates a third random sample, okay, that contains twice as many data points, right? So he has 60 data points right here, okay? The histogram represents this third larger sample is shown below. Based on this sample is a change in the process making bagels warranted. All right, so here, okay, we can see that this is symmetric. Okay, and the mean and the median are both 90 grams. Okay, so the data points are symmetrically distributed around the center. The mean and the median weights are the same. Based on this large sample, the quality control manager determines that the process of making bagels does not need to change because they are centered. Okay, so basically, anytime the mean and the median are the same, okay, then the bagels are good. All right, so 4, suppose that the quality control manager adds 10 bagels to the third sample. 5 are 78 grams, all right? So 5 would be right here. Okay, this is 78 grams. And then 5 are 106. Okay, So even if we were to add 5 to each side, this would not affect the median or the mean. So no changes need to be made. Okay. Because we added 5 on each side, the mean is still going to stay the same. Okay, it's not going to skew it right, it's not going to skew it left, and the median is still in the middle because we added 5 to each side. Okay, so we can still say it's good. All right. So just a little note down here. Okay, so when data displays are skewed right, the tail of the graph goes to the right. When data displays are skewed left, the tail goes to the left. Right, so it's whichever side the tail is on is where the skewing is. All right. Okay, and last example, we're just going to talk about this real quick. But Jennifer is considering job offers from 3 different school districts. The histogram shows the salary changes for similar positions in each school district. What do the shapes of the data tell Jennifer about the teacher salaries? So this one right here, okay, we can see that it is fairly symmetric. Okay, so they center around the mean. This indicates that the salaries of the teachers are fairly evenly distributed. Okay, so you got your newer teachers, you got your older teachers, and you got the majority of your teachers here in the middle. Okay, over here, okay, the mean is 48, the median is 42. But notice that the salaries, these are skewed right. Okay, so this indicates that there are only few teachers that make a high salary. Right, so she would not want to work here. Okay, and here the data from teachers in school district 301 is skewed to the left. Okay, so we can say it's skewed left. And most of the teachers with similar positions have salaries that are higher than the mean. This indicates that there are more teachers that make a higher salary. So this one might be where the new teachers make less, but as you get experience, they make more and more. So she may want to work here or may want to work here, but this one may not be as good. Okay. So suppose a 4th school district offers Jennifer a job. School district 401 has a mean salary of 57 and a median salary of 49. Should Jennifer consider a job accepting the job? So this one is skewed. Okay, these are greater, so it's going to be skewed to the right. So for this particular one, all right, she would say no, right? Because the money is not evenly distributed. Okay? All right, so she wants the job where more than likely it's evenly distributed. So she wants to work here. Okay? All right, guys, so you've got a lesson on Pearson Realize that you should be working on. We're not going to do the bottom example down here. All right, so go ahead and get to work on that, and you can turn your Chromebooks up in when you finish.